Hi friends, welcome back to my channel. In this video, I'm gonna talk about how face recognition system works. For those that are new here, my name is Neo and I am a master's student of AI study in Leuven, Belgium. I am creating weekly videos about my study life and share the knowledge that I have been learning about AI. So if you want to see more content like this, make sure to click that subscribe button and turn on the notification bell so that you can see my weekly update. So without further ado, let's get started. So what is face recognition? So face recognition, you are given images and videos that contains human faces, and this application is gonna detect the faces and also identify whose faces are. A typical application is the security systems in the airport. So when you are going through the security check in the airport, normally it requires you to do a face recognition. So you make sure that whoever is taking the flight is matching the identity of the actual person. So now we're gonna take a look at the building blocks of face recognition. So on the left side, we have the images which should contain the people's face. And the first step we want to do is the face detection. Through the face detection, we are able to extract the face images from the original image. And after that, we're gonna do a face alignment, which is basically turning the faces into more center and horizontal way so that it can be used for the next module, which is the face representation. In the face representation, we're gonna extract some features from the face images. After we get the features of that face, we're gonna use it for a face matching. The face matching is basically to see how similar the extract feature is close to the one that we have in the database. It can be used just to directly predict the identity of the person, or it can be a just simple yes and no answer. Now let's first take a look at the face detection and the face alignment. These two steps, I would call them the pre-processing step. So as I said, face detection is basically to find the position of the face, and after that, it's gonna return the coordinates of a bounding box for each face images. So on the right side, you can see that we detect two faces from the images. One of the popular algorithm is the hard cascade, which we can easily implement with OpenCV and Python in a few lines of code. And for the face alignment, it is to make the face image to be center and horizontal so that we can learn the feature better. It is basically scale and crop the face images in the same way using a set of reference points. We are using a landmark detector to find a set of facial landmarks. So on the right side, you can see that we are actually trying to find the facial landmark of those two faces. So we are using the landmarks such as here we have the center of the eyes, and we have like the position of the nose, and we have the left and right side of the lips. So you can see that for both two images, those points are actually in the same position for this face images. And you can notice that there is a slight rotation if you compare this to the original images here. So now let's move on to the face representation. This is probably the most important module of the whole system. So here we are trying to transfer the pixel value of the face images into a compact and also discriminator feature vector, which we will call as template. Ideally, all the faces of the same subject should map to the similar feature vectors. We have so for the transform method, before the deep learning is the feature-based such as HOG and SIFT, and we have holistic method as well. A typical method will be PCA, which stands for principal component analysis. And before deep learning, actually the state-of-the-art face recognition used a hybrid version of the previous two. So on the right side, you can see a visualization of the uh, feature-based method and also the holistic method. So after we select the appropriate features for our images, then we want to actually use a classifier to classify those input features. Here you can consider this as a machine learning problem right now because you are basically having a high dimensional or feature vector and you're gonna pass it into a classifier model and then it basically tells you the a labeled class. Now you have the input is a high dimensional vector, so you can consider classifiers such as neural network and SVM. However, if you are using deep learning, those two modules can be just combined into one. A very typical example of this is CNN, which stands for Convolutional Neural Network. However, the deep learning always requires large number of training data so that it can achieve some good result. Here we are talking about at least thousands of input training data. So to summarize this video, face recognition system consists of face detection, face alignment, face representation, which is basically face extraction, and with last but not least, the face matching. Among those components, the face representation is the most important one. Deep learning approach typically requires much more training data than the traditional approach so that it can achieve better prediction than the traditional one. So that concludes this video. I hope it is helpful for you. And if you find this video helpful, don't forget to subscribe and like, and I will see you in the next one. Bye bye.